Hello and welcome to another video, this time going through question 1 from Stats 2022. It's a discrete random variable question, well actually a binomial distribution question, and then it's got a normal approximation to binomial at the end, which can definitely come up. Okay, so first couple of questions, well we've got George throwing a ball at a target 15 times. Each time the probability is fixed. So it certainly sounds like, assuming George isn't getting any better when it doesn't look like it as well if the probability is fixed, that the assumption of independence holds, and so we can say x is binomial and there's 15 trials and there's a 0.48 chance of success. And to work out this first one, we're just going to do binomial PD and binomial PD here, because remember PD is equals and CD is less than or equal to. So on binomial you might use PD, but on normal distribution you will never use PD. Yeah, that's one thing I would like to explain. That's really important. Okay, let's work this out then. So after that we just type it into our calculators, go into statistics, binomial distribution, binomial PD, n is 15, p is 0.48, x is 3. You should get 0.019668, and that obviously rounds to three significant figures to 0.0197. Cool. Okay, here's the trick they're doing. I wouldn't be surprised actually, by the way, if in your exam they do this as a strict inequality, because that always confuses students more. Every time I've seen them in these papers they're doing it as or equal to, which makes it slightly easier, because what is the opposite of 5 or more? It's 4 or less. So we might need to do 1 minus the probability of 4 or less, and that's just because our calculators don't do greater than or equal to, and CD they only do less than or equal to. And if you do that you should get 0.92013, so 0.920 to three significant figures. Okay, so those are pretty standard kind of questions. Like I say, watch out though in your exam. Maybe they change this to a greater than 5, yeah, which is really greater than or equal to 6. And so you do for that 1 minus the probability that is less than or equal to 5, yeah. Watch out for that. I can imagine that kind of thing coming up. Okay, last bit. George now throws the ball at the target 250 times. So this is a normal approximation question. Now I like to remind students basically, in normal approximations, I tend to notate it like this. I tend to say, okay, x is binomial with n is 250 this time and p is 0.48, but we're going to approximate that to y, which is normally distributed, right, and now you put np in here and the variance will be np times 1 minus p. I believe that is kind of given in the formula book as well on one of the pages, so look it up if you don't remember it. Now n times p, I'm just going to quickly do that on my calculator. 250 times 0.48 is 120. Yeah, and then we're going to do let me just check that. 250 times 0.48 is 120, yeah, and then we're going to do times by 0.52, that last answer, and we get 62.4. But remember, I always write this down, that I'm going to use square root of 62.4 because I want standard deviation for my calculator, yeah. Now this is the way I set out my working here. Now the one thing that students forget in these questions is the continuity correction. Yeah, and you always have to use that in any binomial approximation to the normal, normal approximation to the binomial, because binomial distribution is a discrete distribution, normal is continuous. And so we're going to find, let's have a look, what do they want? More than 110 times. So we're going to look for the probability that x is, now if you're more than 110, then you're 111 or more. So I'm going to change that straight into 111. You don't have to, but I think it'll be easier to do that. And I'm going to write that roughly equals the probability that y is greater than or equal to. Now this will not be 111 because of the continuity correction. In order to work out the continuity correction, I normally draw three silly bars like this, and I draw my normal distribution line going through the bars. That's because, actually, I might quickly show you this, because there's a lovely GeoGebra distribution, a lovely image from GeoGebra on this kind of thing. Let me see if I can... Okay, this one only goes up to 100, which is a shame, but that's okay. We might, yeah, I might actually, if I can just take a screenshot of this. Why won't you make it bigger for me? Okay, it's not making it bigger at the moment. I'll tell you what, I'll just quickly screenshot it because it's on my other screen. I just wanted to show you what this really looks like, because I think it helps your understanding. Okay. can you see on here we've overlaid the normal curve on top of the binomial? Now this is in the case where n is 100 and I've accidentally clicked on p is 0.47, but the principle holds. Can you see that the normal distribution curve is going through the middle of the binomial distribution bars? And that's why we need this continuity correction, because to estimate it, it's more accurate if we make that little continuity correction. That's the key thing. Okay, so let's go back to our question. Let's get rid of that. It's kind of in the way. There we go. Okay, so we're doing this continuity correction. Give them a label around the values that we're interested in of 111, 110, 111, 112. Okay, we want 111 included, yeah, and we want greater than or equal to. So can you see there, we're going to go from 110.5. You just need a rubbish little sketch like that to determine this. Okay, right, brilliant. Okay, and that is, and actually, sorry, I've done this wrong. Yeah, no, this is looking good. No, this is looking great. Absolutely brilliant. Sorry, I'm just having a sip of coffee here. Now, we want the probability that x is greater than or equal to 111. But that roughly equals the probability that y is greater than or equal to 110.5. And now we're just going to run through it's often in the mark schemes they'll show you z distributions, but you don't need that here because your calculator works this out automatically for you. And if you go straight to the answer now by using your normal distribution on your calculator, you're going to be using normal CD. Yeah, let me just write that down, normal CD. And you're going to be using the limits of 110.5 for the lower limit. The upper limit can be like a million or whatever, you know, just put a 1 with a few zeros after it. As long as it's a few standard deviations above the mean, it will be fine. And then you're going to put the mean in as 120, and you're going to be putting the standard deviation in as square root of 62.4, and that should spit out the answer as 0.885 to 3 significant figures. And that's all there is to it. Okay, I hope that makes sense. The continuity correction is where people normally go wrong. And make sure you remember n times p times 1 minus p. Okay, thanks for listening. I hope you found the video useful, and best of luck in the exams. Bye-bye.